I were to draw this picture, I have a 75-degree, 30-minute angle opposite a 13.2 centimeter side, and then 17.9 on there, right? And so I use the 75-degree, 30-minute angle. Now you might want to use the law of sines this way. You don't have to, but it just makes your solving go a teeny tiny bit faster when you're solving for an angle. Equals the sine of angle A over 17.9. Everyone agree? Okay, so if you multiply the 17.9 over, you get sine of A equals what? 1 point something? Okay, and I would keep all the decimal places, don't round, and use your calculator. To find angle A, would you do sine inverse? What happens when you try to do sine inverse? Can sine ever be bigger than 1? No, right? Sine's between -1 and 1, so sine of an angle can't be that. Do you see why your calculator is giving you an error?
Whoa.
So that's a problem, right? This is not a triangle. It doesn't make a triangle. We're going to find out why. It is angle side to side, which creates problems. So today we're going to learn about those problems. We'll figure out why that didn't work first. Okay, so if the lengths of two sides and an angle opposite one of them are given, so we have a side-side angle case, the bad one, right? We talked about that yesterday. Then 0, 1, or 2 triangles may exist that fit that case. Obviously, on the bell ringer, it was not a triangle. You can try it all day long, but it's not a triangle. You're not going to find one that has that side angle combination. So those to me are easy because you can try them, but it's not going to work. So you know there's not a triangle there. So we're going to be looking at the 3 different options. There's either 1 triangle, no triangles, or 2 triangles that fit the bill. So that's what we're going to be looking at. So the 3 cases. And we're going to walk through this slowly, give you plenty of time to write and process. The first thing we're going to talk about is if A is acute. And then there are 3 cases, but they have 4 here, but 3 or 4 cases for what kind of triangles we can have. To help you figure this out, always draw the triangle where the given side, this is the given angle, and this is the given side, and this is the other given side. Even if the letters are not A, B, and C. So kind of forget A, B, and C. In fact, in your notes, you want to call them X and Y. That way, when it is A, B, and C, you can just change it to fit your letters. But you want to always draw it where you have your angle side combination here, and then the other side here. We're going to set it up that way. It'll help you pick out which case we have. But the first thing I'm going to do is find the height of the triangle in this form. Wouldn't you agree that the sine of angle A would equal H over B? Everyone agree with that? So the height would be the sine of A times B. If my other side, like side A, is shorter than my height, is it going to make a triangle? Is it going to reach? Let's go back to this one. Time out for just a second. Find that height for me. Everyone do that for me. Find the height of that triangle. How did we do that for my this side and this triangle here, if we actually had correct lengths, doesn't reach. So everyone see what I mean by that? There's no way you can make that triangle. The triangle's too short. Want to see that? So that's why we got that weird, there's no triangle case. Okay, so that's case one, is there's no triangle. Because the side opposite the angle is smaller than the height in the triangle. It's too small to reach. The other case is where the height equals the other side. In that case, there's one triangle, it's a right triangle, right? If the height equals that side, then you have a right triangle. And there is one triangle that fits that, and you could just use your right triangle trigonometry to solve that triangle if you wanted, because it's a right triangle. If side A is bigger than H, then you only have one triangle, and it's that picture here. Side A is bigger than the height. That's probably the one you would have drawn. That's probably what we would have thought would happen. Is if side A is bigger than H. Or sorry, bigger than B. Bigger than side B. If side A is bigger than side B, I have a triangle. It's bigger than both H and B. The weird case, the very strange case, the one that's going to cause us the most fits, is the last one, where there are two possible triangles. If side A is bigger than the height, but smaller than side B, then there are two ways I could draw the triangle. I could draw it the way that you would normally think to draw the triangle, or I could swing this side in and draw this triangle. Everyone see that? So if side A is bigger than the height, so it makes a triangle, but smaller than the other side, then it makes two triangles. So that'll be the case that's a little tricky today that we will learn about. Again, I want to make sure that you do not get caught up in the letters, because if you do, the letters are going to change on the triangles. They may call C A, A, C. So don't get caught up in what the letters are doing, but how the triangle's set up. Okay, this to me is a little easier. This is when you have an obtuse angle that's given. So the other two, we had an acute angle that was given. These, we have an obtuse angle that's given. There are two possible outcomes. Either the side A is too short to reach, or it's not too short to reach. One of the two. And you don't have to worry about a height on this one or anything. You just have to compare it to side B. If side A is shorter than side B, it's not going to reach. If side A is longer than side B, it will reach and make a triangle. So there are two cases with obtuse. Those are much easier to pick out. Now, let me remind you of something for a moment, because that last slide was intimidating, wasn't it? How many of you knew on the bell ringer, without me teaching a single thing, that did not make a triangle? Why? It didn't work, right? So you can pick that out to begin with. So the focus of our day is going to be spent on that case where there are two triangles. One triangle, you'll be good. No triangles, you'll be good. You've done both of those before. You've dealt with those cases. You can handle that. The one case that is new to us is, what if there's two different triangles it could be? How could I find both of them? And so that's the weird case. Any questions about that?
Wait, so like the last one on the last slide, basically it would be forming the last triangle on this slide.
No, because it would be, the angle was acute. See that little
No, I'm saying like that angle right there, like on there's an opposite angle.
There is, but it wasn't a given angle.
Oh,
Does that make sense?
yeah. It's just gonna form a triangle like that.
It will. Okay. Again, don't get caught up in the letters. But if the given angle, yes.
What if the given angle is a 90-degree angle?
Then work it with a right triangle trig. Never use law of sines. Did everyone hear that? If the angle given is right, then this is all unnecessary thoughts. Because you can just use right triangle trig to find these sides and angles of the triangle. Because you can use Pythagorean theorem to find a third side, and then you can backtrack and use the law of sines to find the angles, and you're done. If angle A is acute, so if the given angle is acute, and the angle or the side opposite that angle is smaller than B, there are three possibilities. Two solutions, if the side is greater than the height. One solution if the side equals the height, and no solutions if the side is less than the height. So that's going to be the one that we are the most concerned with. If angle A is acute and A is greater than B, then there's one solution. That's that big, long side triangle. And if A is obtuse or right, there are two possibilities. Either there's no solution or there is a solution, depending on if the side's long enough to reach or not. I'm going to give you a minute to write this down. This is a nice summary just to have handy. We are going to spend several days on this section, so you don't have to fully process it. Okay, so we're not going to solve yet. We're going to do more than this. Determine the number of triangles possible with the given parts. So I just want to figure out how many triangles could I get. So I'm going to draw the picture. I highly recommend drawing the picture because, again, A and B may not be the same A and B from the picture on the left side. So I I'm going to draw the picture to figure out what I've got going. So I have, this is always the picture I'm going to draw, where the given angle goes here in the bottom left corner. Everyone always put whatever angle they give you in the bottom left corner. Not because that's right, it's just the picture, all the pictures I showed you, it was that way. So trying to flip it in your head would get tricky. So just don't try that. Always put whatever, if it's angle C they give you, put it over there in the bottom left. Side A has no choice, right? It has to go over here. And then put the other side they give you over here. Okay. So I want to know, well, what case is this? This is, to me, the easiest case. This side is longer than that one. Forget it. One triangle, done. Why one triangle?
Obtuse angle.
Oh, good. I didn't draw it that way. It is an obtuse angle. A is. That side is longer, and we have an obtuse angle. The given side across from the angle is longer than the other one, so it will reach. It will make a triangle. There will be one triangle. Any questions about that? No? Okay, let's look at the next one. Again, it gives us different letters, so you can see why I'm going to set up the triangle the same every time. Bottom left corner, I'm going to put the 48. So that means 26 has to go over here, 31 has to go over there. Maybe this is a problem. Why is maybe this a problem? The 26 is shorter than the 31. So I have a question. Is this one triangle or is this no triangles, one triangle, or two triangles? Based on how short is this, right? How short is 26? So before I can continue, I need to know how big is the height. And you saw in there they called it B sine of A or something like that. But what are we doing? We're finding this height really quick. So I have the sine of 48 degrees equals h over 31. You see how you don't have to know a formula to do this? You can just use the thought process. The formula is nice. The problem with the formula is when they switch the letters, people get really confused fast. So just be careful with, you know what I mean by that. 31 sine of 48. What is 31 sine of 48? 23? Okay. So does it make a triangle? It makes two triangles. Why does it make two? One, it's just the case. Now let's talk about the picture. This side is shorter than that one, but it's longer than the height. So that means I can swing it, and I'm going to redraw it to fit that. Now that I know that. This triangle looks something like that. Right? Say that side's not over here. You see what I mean? Right. So it could be this red triangle, or it could be the green triangle. I don't know which one it is. That's why there's two possibilities. Nothing would let me know which one is which. So there's two triangles. Because of that possibility of swinging it in.
So that's 26, that side is less than the 31 side, or bigger than the height.
That's right. So if the 26 is less than the height, or more than the height, but less than the 31, there's two triangles. Because it's able to swing. Do you see why one longer than 31 wouldn't be able to swing?
Yeah.
It'd be too long to fit. Yeah, if this is longer than the other one, it could swing. Okay, let's look at number 3. It's not that one. How am I going to draw the picture to help me set it up?
58 degrees and 58 degrees.
58 degrees in the bottom left. And And if 50 has to be opposite, 61 has to be over there. So I need to know how big is the height, right? That's really every time that one of these triangles pops up, that's my question. What's the height? And the height.
Speaking of the Senate, your attention please. We need Cheyenne Horton and Devin Horton to the office, please.
51.7.
That was Kylie Horton to the high school office.
What does that mean? It's not a possible triangle because the height, that's the shortest distance that I could get to that top point down at the bottom, right? It's the height. And so if I can't make it there with the height, if I don't have the full height, then I can't make a triangle. Now, we're just figuring this out without doing any work. If you get stuck, try to make one. Try to find the sides. What would your calculator say when you tried to find that other angle?
Error.
It would say error. So, kind of a foolproof option when you get on the test if you don't know the answers. Right? Now, the one thing you're doing that can't do is find the second triangle, which we'll talk about. But it can help. Okay, so is this the color? Yes, is it the same?
Yeah.
Well, we're skipping it. Here's the picture. So, we already did that on the gallery here. That's the picture from it. It didn't make a triangle because the 13 is just too short. Okay. Let's try this one. Before I solve it, I would like to know what I'm looking at. How many answers are there? How many triangles are there? So that's step one. So I want to find out how many there are, and then I want to find all the sides and angles of the triangle or triangles, if that's the case. So, I'm going to put angle A, bottom left, side A, across from angle A, and the other side that's given. What do I need to find to know if this is a triangle or not? I need to find height. And what is the height? So is this a triangle? Yes, and there's two of them. Because it's the opposite side of the angle is in between the height and the other side. Which means it's two triangles. So this is going to be the hard problem of the chapter. I need to now solve for two triangles. So it almost feels like it's double the work. It's not quite double, and I'll show you that as we go. Step one, find just whatever triangle pops out when you use the formula. Okay, just find a triangle first. This side, the height was 34, is that right? 34. So this side is longer than height, so we know it makes a triangle, but it's shorter than that. So that means it's short enough to swing in and make two triangles. So what this triangle really looks like is it could be here or it could be in there. That makes sense. This third side could be this dotted line, or it could be that. Remember, I don't know how long this side is. I don't know that length. It could be the short side with this little triangle. It could be the longer side with this triangle. So I don't know that because they're two options. That makes sense. Okay, so step one, I'm going to solve whatever triangle pops out when I use the formula, the law of sines. I could have done this if I had never taught you two triangles. One of them you can find. Even if you didn't know there were two, you can just start plugging things in and you'll find a triangle, right? The other triangles that tricky part. So let's find a triangle. And so we have sine of 61.4 over 35.5 equals, what was that side? Sine of angle B over 39.2. Multiply sine times 61.4 divided by 35.5 times 39.2. And then what do you do after you get that number?
Inverse
Sine inverse that number. You want the angle B. And we are in degrees, so it's your calculator in degree mode. You make that happen. 75.81. I'm going to solve. I want you all to find that in your calculator. Give me 3 decimal places. If you are working this whole problem, make sure you keep that number in your calculator. You can either use the store button, you can store it as alpha A and then use A later, or actually I would pick B if I was storing it, I'd store it as B. You could do that and use it throughout the problem, or you can just go up and grab it. Do you all know what I mean by that? But use the calculator stored values. Do what? Oh, the store button is right above the on button. So as it's sitting there, just push store as alpha B and push enter. And it'll, then anytime you type B, that number will come up. Okay, what else do I need to find? Angle C. What is angle C? And how do you find that? 180 minus the other two. No lost signs there, right? We're just subtracting from 180. So what is angle C? 42.79. 79. 789. All right, so that's angle. Both of the angles. And what's the last thing I need to find?
side C.
Need to find side C. How do I find side C?
All signs here.
All sides again. I would stick with the original ratio. Everyone know why I would stick with the original ratio? Because I didn't calculate it, so I'm less likely to mess it up. So stick with that original ratio and now use the, I want to find side C, right? Actually, I'm going to flip the ratio. You can do that however you want. 5 over the sine of 61.4 degrees equals side C over the sine of 42.789. And what do we get for side C? What did it give us in it? Any questions so far? Okay, now I've found one triangle. First of all, I want to know which triangle did I just find? Big one. How do you know?
This is not a giant obtuse angle.
There's not a giant obtuse angle, right? So none of those were obtuse. Well, why not? Is sine inverse ever going to give you an obtuse angle? No, it's always going to give you an acute angle because it gives you angles between negative pi over 2 pi over 2 or negative 90 to 90. So sine inverse isn't capable of giving you that obtuse angle. So this will always find a big one. So now I'm going to draw a careful picture. And I want to talk about how to get the other triangle because that's the new thing for the day. I am not going to use trigonometry to do it. I'm going to use geometry. I already know this angle here, right? Everyone agree? I found this angle. It was angle B. Okay, so that's my first B angle that I found. Okay. Any questions so far? The triangle that I'm trying to find now is this obtuse triangle. blue triangle. That's my goal. Any ideas? Well, we will eventually, but first I'm going to use some geometry to find part of it. Because it's easier. The law of sines will not give you that other angle if sine inverse can't give you an obtuse angle. Now you might find it. The other angle that sine inverse you might figure that one out. We're going to do that yet. Okay. Good. When you agree this is this triangle, which has nothing to do with anything we're trying to find, that triangle happens to be isosceles because you swung the side in, so it's the same side. So isn't this angle and this angle the same? So would this angle, which I'm going to call B2, be supplementary to the first B we found? Does that make sense with why sine inverse didn't find it? Because wouldn't there be an angle in quadrant 2 that has the same reference angle that sine inverse is incapable of finding? The obtuse angle? What I mean by that? So, write this in your notes. To find the first angle, right? To find the first angle, you're going to find the second triangle. It's always the supplementary angle to the first one you found. So step 1, when I'm finding the second triangle, I'm going to go back up and see what the first angle I found was, and it was angle B. I'm going to go back and call that B1, just so I know there's two different B's. Angle B2 is 180 minus B1. It's supplementary to the first one I found. And so that first one I found was 75.811 or something. Now you have it stored in your calculator, you can scroll back up and get it. So what is angle B2? What is it?
104.189.
Okay, so that's the second angle B. You always do it that way. If there are two triangles, in fact, once you found the first angle, you could go ahead and just find that second angle. And now we're going to solve a separate triangle with that new angle in B2. The law of sines works perfectly fine when you have an obtuse angle. The problem is when you're trying to find an obtuse angle. The law of sines can't do that. Does that make sense? So now I have angle B. I have angle A. And now I need angle C. Will angle C be different? Yeah, because it's right. So how do I find angle C? 180 minus A and this different B angle. And what is it? And then what's the very last thing I need to find? The little side C. I expect it to be smaller than the answer I got on the first triangle because now it's that little side. And so I'm going to use the same setup I did to find the side C to begin with, except the only thing I'm going to change is my angle. 35.5 over sine of 61.4. Equals C over the sine of 14.411. And so what do you get for little side C? And what was the first answer for C? So does it make sense that that's much smaller? Yeah. Alright, so that's the bad stuff from this chapter. Any questions so far? We okay? We will, of course, do another one. Alright. Try it out. It says without using a lot first of all, and then we'll go up the side. So, you know how I got the angle B? Then I know angle A and I know angle B. So to find angle C, you just subtract both of those from 180. Angle A was given. This is my angle B. Subtract both of those from 180 to get the other angle in that little triangle. So that's how you find angle C. That was the question. It wasn't the side, so I answered. The first worksheet that is coming around is due on Tuesday. It is due before this one. Monday we're going to have finish notes / workday. Go ahead and do as many of those as you can, especially numbers 1 through 4, where you're just deciding how many triangles there are. Do all of those. On 5 through 10, that's where you're actually finding triangles that you may only have to find one. You may have to find none. Your favorite answer on this is that there's no triangle, right? You don't have to do anything. And then the second worksheet. Tuesday. I think I have this. I'm going to go ahead and get it to you though. I want the first one done Monday. I really do. I just want to give you a little leeway time in case you have all your stuff. So I'm giving you a grace period day, but hopefully you get the first one all done tonight. It's only 11 problems. That one, I believe I have to Wednesday. It's not. This weekend, don't worry about it unless you just have extra time and want to get it done. But this weekend, try to do the first worksheet. That worksheet will save for Monday night to do. One more. Which one? Hopefully there it is. Putting in that file. Okay. So without using a lot of lines, why is there no triangle? Okay, good. This is an obtuse angle. That's got to be the biggest angle, right? The opposite side has to be the biggest side. Well, this is 42 over here, but this side is 48. So that's not going to reach because that has to be the biggest side, has to be across with the biggest angle. That makes perfect sense, right?
Yeah.
That's not really the law of sines, but it's one of our cases, right? You can use geometry to think through some of these problems, or you can use the law of sines. Ignore that. Okay, so you have your homework. Any questions for me?
Well, the second worksheet.
Do what?
We don't have that second one.
The first